Section 11.3b is about extraneous solutions. Squaring each side of an equation sometimes produces extraneous solutions. An extraneous solution is a solution that you find, but it doesn't actually work when you plug it back in. So let's take a look at how we're going to get those. Here we're going to isolate the radical, which is already done, and then square both sides. Now this one's more complicated than ones we've done in the past, because the left is x plus 2, but the right side is x minus 4 times x minus 4. And that has to be distributed or FOILed, or if you remember the perfect square trinomial, it's going to be x squared minus 8x plus 16, using the pattern that we learned back in Chapter 8. Now since we have a polynomial with an equal sign, a polynomial equation, we've got to go back to Chapter 9 and solve that with the zero product property. So I'm going to subtract x from both sides and subtract 2. So we'll end up with x squared minus 9x plus 14, and that all equals 0. If you remember the zero product property, we now have to solve this. So diamond, multiply the 1 and the 14. We need two factors of 14 that add to give us a negative 9. I would say negative 7 and negative 2. So we can factor this as x minus 7 and x minus 2 using the short version that we learned, and that equals 0. Setting each group equal to 0 and solving, you don't have to do this step if you can do it quickly in your head, but I'm going to do it for those that don't remember. X equals 7, and then adding 2, x equals 2. So we've actually discovered two solutions to this radical equation. But now, if I take the original equation, square root of x plus 2 equals x minus 4, and I plug in 7, let's see what happens. So 7 plus 2 is 9, so this is really a square root of 9, equals 7 minus 4, which is 3. And does the square root of 9 equal 3? Yes, it does. So that answer is good. Let's do the same with the x equals 2. 2 plus 2 is 4, so square root of 4, and then 2 minus 4 is negative 2. Does the square root of 4 equal negative 2? No, it does not. So we say that this solution, this x equals 2, is extraneous. It doesn't actually work, and therefore this radical equation only has one solution of a 7. Now this happens more often with radicals than it does when you're just solving quadratics like we did in Chapter 9. So I'm going to tell you that you have to check all your solutions by plugging them back into the original to see if there's any extraneous solutions. Here we isolated the square root, so we will square both sides. 2 minus y equals y squared. Now because that y squared, I'm thinking I'm going to have a trinomial, so I'm going to isolate, or I'm going to get one side equal to 0 by adding y and subtracting 2. And that's going to give me a trinomial of y squared plus y minus 2. And that equals 0. So we have to factor this trinomial using the diamond, negative 2 on the top, 1 on the bottom, which means two factors that multiply to be negative 2 and add to be 1. Positive 2 and negative 1 should do it. So then I get y plus 2 and y minus 1, which means my two solutions will be negative 2 and positive 1. Now they both might work, but they both might be extraneous. We have to check. So square root of 2 minus, I'm going to plug 2 in. Oops, that's a negative 2. So square root of 2 minus negative 2, and that equals negative 2. So 2 minus negative 2 is 4. So this is really the square root of 4. Does that equal negative 2? No, it doesn't. So negative 2 is extraneous. And then we'll do 2 minus 1. Does that equal 1? Square root of 1 equals 1. Yes, it does. So in this case, there's an extraneous solution, and my answer is 1. Now I'm going to continue to do examples here. You may understand this idea of extraneous solutions, but I do think it's important if we continue to do some examples to remind us of Chapter 9, just some things that we learned back then. So I'm going to keep doing these examples. Take the square both sides to get rid of the square root. You get 2a squared minus 144, and that equals a squared. So I'm going to subtract a squared from both sides. 2a squared minus 1a squared is a squared minus 144. This is a binomial, and if you go back to chapter 9, we check for a difference of squares, and this is because a squared comes from an a times an a, and 144 comes from 12 times 12. So one's a plus, one's a minus, and then my two solutions would be negative 12 and positive 12. We've got to check both of those solutions to make sure they work. So over here I have the work. Positive 12 works just fine because you plug in 12, you do the work there, you get square root of 144 equals 12. But I want to show you something about negative, and it also happened back here in this example when I had equals negative 2. If you ever have a square root equals a negative, we talked about this before, that you can't have a square root that equals a negative. So if you ever have one like this where it equals a negative number with a square root on the other side, you can immediately know that that one's not going to work, that that's going to be extraneous. So in this example, 12 is my only solution. Now for this final example, something very interesting is going to happen, and I really want you to try to pay attention to this one and focus on it. I'm going to start by squaring both sides, which we've been doing. So 2x squared minus 12 equals x squared. And then I want to set it equal to 0, because that's typically what we do. So you get x squared minus 12 equals 0. Well, now we get to something interesting. This is not a difference of squares, because 12 is not a perfect square. So we cannot factor this using the methods that we used for factoring. But if you also remember, instead of using a zero product property, we did something called the square root property back in chapter 9. So I'm going to add 12 to both sides and get x squared equals 12. And now we've spent the whole chapter getting rid of radicals. This might seem weird to you, but now I want to get rid of the square because I want to isolate the x. And we can do that by taking the square root of both sides. So we will cancel those out and we'll get x equals plus or minus the square root of 12. Remember, when you introduce a radical sign, you introduce the positive and the negative version. Now I'm going to simplify this square root of 12 using the things that we've been doing in this chapter. 4 times 3, and the reason I chose 4 is because the square root of 4 is 2. So this is really plus or minus 2 times the square root of 3. Those are my two solutions. Well, as I talked about in the last slide, if it ever equals a negative 2 times root 3, no matter what the square root is, you can't have that. So you know that the negative version is not going to work here. So in this case, the solution then is going to be 2 root 3, because the negative just won't work.